Hi, I'm Teacher Thomas. Welcome to math class. Today's topic is coordinate geometry, circles. We have an example problem that we will work through. Before beginning, I want to talk about some general concepts regarding circle equations. The standard form circle equation is x squared plus y squared plus 2gx plus 2fy plus c equals 0. And you should be able to use completing the square methodology to get to the completing the square form, which is quantity x minus a squared plus quantity y minus b squared equals r squared. In the completing the square form, we can identify the center of the circle as a comma b. Those are the x and y coordinates of the center. And the radius of the circle is r. So let's look at our example. We have points of intersection. We don't know how many, but we know more than one since points is plural, of a parabola and a circle. We don't need to use graphing. We could graph to get an idea of whether our answers are reasonable, but we're simply going to work through the algebra to find our points of intersection. In the first equation, y is to the power of 1, so that's the simplest option for me to use substitution for. In other words, I'll take the y value of the parabola, which is x squared minus 2, and I'll input that into the y value of the circle. So we'll begin with x squared plus quantity y minus 1 squared equals 9, and now that y becomes x squared minus 2. I'm substituting in, replacing the y with the value x squared minus 2 from the equation of the parabola. Now we have an equation in one variable. We can solve for x. Incidentally, our circle equation, if we want to find the center, we see that the x term doesn't have a constant value. So the x coordinate of the center is 0, and the y coordinate of the center is 1. The center is 0, 1, and the radius, r squared, is 9. So the radius is 3. We don't need that information to solve this problem, but it is a good example of how to identify the center and radius of a circle when your equation is in completing the square format. Let's continue to solve the equation we're working on. X squared plus quantity x squared minus 2 minus 1 is x squared minus 3 squared. I'll move my 9 over because I'm going to be working with a quadratic, or at least a quadratic, perhaps a higher power. When I expand, I have x squared plus, now the expansion, x to the power of 4 minus 6x squared plus 9 minus 9 equals 0. The 9's offset. We have 2x squareds. I'll simplify to x to the power of 4 minus 5x squared equals 0. One further simplification is to factor out x squared from both terms. X squared times x squared minus 5 equals 0. If x squared equals 0, or if x squared minus 5 equals 0, this equation will be true. What x value causes x squared to be 0? When x is 0, x squared is 0. X squared minus 5 equals 0 when x is either, actually let's go one more manipulation, x squared equals 5. What value of x results in, when squared, results in 5? X is either the square root of 5 or x is the negative square root of 5. So we have 1, 2, 3 x values. Our requirements are to find the points of intersection. There are 3 points of intersection. These are the x values. We'll input these x values into one of our equations to find the corresponding y values at each point. We'll use the parabola because that's the simpler equation. So for x equals 0, we have y equals 0 squared minus 2, replacing the x with 0. Y will simplify to negative 2, so our first point of intersection is 0, negative 2. When x equals the square root of 5, again using the parabola equation, y equals now the square root of 5 squared minus 2, which simplifies to 3. The square root of 5 squared is 5. 5 minus 2 is 3. Our second point of intersection is root 5, 3. And for x equals negative root 5, y equals negative root 5 squared, important to use brackets, minus 2. Here we also have a y value of 3. And our third point of intersection is negative square root 5, 3. We've identified 3 points of intersection of the parabola and the circle. This completes the requirements for our problem, and this completes the lesson on coordinate geometry circles.